Stop dyeing your gray hair. I know that sounds strange coming from a doctor. I know that for years, maybe even decades, you've been making that familiar trip to the salon every 4 to 6 weeks or standing in front of your bathroom mirror with a box of hair dye, gloves on, timer set, hoping that this time the color looks just right. Maybe you've become so used to the routine that it feels like another household chore, something you simply have to do. But today, I want to ask you to pause for a moment before you reach for that next bottle, because what is happening to your hair is not simply a cosmetic issue. It isn't proof that you're getting old too fast. It isn't punishment for something you did wrong. It is the result of biological changes taking place deep inside your hair follicles. And once you understand those changes, you'll begin to see your gray hair in a completely different light. For years, we've been told that gray hair is inevitable, that once those silver strands appear, there is nothing left to do except cover them. Most people accept this explanation without ever asking why it happens in the first place. But science has taught us something fascinating over the last several decades. Aging is rarely caused by a single event. Instead, it often reflects a gradual shift in countless biological systems working together. Hair color is no exception. The loss of pigment isn't simply about birthdays accumulating on the calendar. It involves enzymes, nutrients, specialized cells, oxidative stress, genetics, overall health, and even the environment surrounding each individual hair follicle. Understanding those relationships can help us better care for our hair, even if it doesn't guarantee that every gray strand can be reversed. Have you ever looked in the mirror and wondered when that very first gray hair appeared? Maybe you remember pulling it out, convincing yourself it was just one. Then another showed up. Before long, they seemed to multiply almost overnight. Did it make you feel older than you actually felt inside? Did it change the way you looked at yourself? Perhaps you've caught yourself avoiding bright lighting because it makes the silver strands more noticeable. Maybe you've spent hundreds or even thousands of dollars trying one product after another, hoping someone had finally discovered the answer. If any of that sounds familiar, I want you to know you're certainly not alone. Millions of people, especially women over 60, quietly struggle with these same feelings every single day. Hair isn't simply about appearance. For many people, it's tied to confidence, identity, memories, and the image they carry of themselves. That's exactly why today's conversation matters so much. My name is Dr. Natalia Wright, and welcome to Dr. Natalia Wright, Senior Health. For decades, I've been passionate about helping older adults understand what is truly happening inside their bodies so they can make informed decisions based on evidence rather than fear or marketing promises. Every week, we explore the science behind healthy aging in a way that's practical, understandable, and respectful of the incredible wisdom that comes with growing older. My goal isn't to promise miracles or sell impossible dreams. My goal is to help you understand your body well enough to support it naturally whenever possible, and to separate genuine scientific findings from myths that have circulated for years. Let me ask you another question. How many products have you purchased because someone promised they would make you look 10 years younger? How many advertisements have told you that one cream, one pill, or one treatment could erase the signs of aging forever? We live in a world where aging is often treated as something to fight instead of something to understand. Yet the human body is remarkably intelligent. When something changes, it usually happens for a reason. Gray hair isn't your body betraying you. It's your body responding to biological processes that have been unfolding quietly over many years. Understanding those processes doesn't just help us care for our hair, it teaches us valuable lessons about overall health, nutrition, inflammation, and cellular aging. One of the biggest misconceptions surrounding gray hair is that it's determined entirely by genetics. You've probably heard people say, "My mother went gray at 40, so I was destined to do the same," or "Everyone in my family turned gray early, so there was nothing I could do." Genetics certainly play an important role. They influence when your hair may begin losing pigment and how rapidly that process progresses. But genetics are only one chapter of a much larger story. Lifestyle, nutrition, chronic illness, smoking, oxidative stress, certain medications, hormonal changes, autoimmune conditions, and nutritional deficiencies may all influence how healthy your hair follicles remain over time. To understand why hair changes color, we first need to understand how it gets its color in the first place. Deep within each hair follicle live remarkable cells called melanocytes. These highly specialized cells manufacture tiny packets of pigment known as melanin. Think of melanocytes as incredibly skilled artists working inside microscopic studios beneath your scalp. Every time a new strand of hair begins growing, these artists carefully deposit pigment into that strand before it emerges from the surface of your skin. If plenty of pigment is delivered, your hair appears dark brown, black, auburn, or blonde, depending on the specific type and amount of melanin your genes instruct your body to produce. Nature has engineered this process with extraordinary precision. During youth, melanocytes work tirelessly, producing pigment continuously as each new hair grows. They receive nutrients, oxygen, and biochemical signals that allow them to perform their job efficiently. Most of us never think about these tiny pigment-producing cells because they quietly perform their work every day without demanding our attention. Yet, like every other cell in the body, melanocytes are affected by aging. Over time, their efficiency gradually declines. Some become damaged, others become inactive. Eventually, some disappear altogether. When enough melanocytes stop functioning, the new hair emerging from that follicle contains little or no pigment. Instead of appearing brown, black, or blonde, it grows in silver, gray, or white. This transition doesn't happen overnight. In fact, many people assume that all of their hair suddenly turned gray over the course of a few months, when the process actually began years earlier. Hair grows in cycles. Some follicles are actively producing hair while others are resting. Because each follicle follows its own schedule, pigment loss usually appears gradually. One strand changes, then another, then dozens more. Before long, the mirror reflects a noticeable transformation. Scientists have spent decades trying to understand why melanocytes lose their ability to produce pigment. Although there isn't one single explanation that accounts for every person, researchers have identified several important biological factors. One of the most widely studied involves something called oxidative stress. Oxidative stress occurs when unstable molecules known as free radicals accumulate faster than the body's antioxidant defenses can neutralize them. Every day, your cells naturally produce small amounts of these reactive molecules as they generate energy. Environmental pollution, cigarette smoke, chronic inflammation, ultraviolet radiation, poor sleep, emotional stress, and even normal metabolism contribute to this process. Fortunately, your body also produces an impressive network of antioxidant enzymes designed to keep these reactive molecules under control. One enzyme that has attracted considerable scientific interest is catalase. Catalase serves as one of the body's natural defense systems against hydrogen peroxide. Many people recognize hydrogen peroxide as the antiseptic solution kept in medicine cabinets for cleaning minor cuts. What surprises most people is that your own body also produces hydrogen peroxide naturally during normal metabolism. In small amounts, it plays useful roles in cellular communication. But when excessive amounts accumulate, hydrogen peroxide can contribute to oxidative stress that affects many different tissues, including hair follicles. Researchers have observed that hydrogen peroxide tends to accumulate inside aging hair follicles, while antioxidant defenses become less efficient. This imbalance has led scientists to investigate whether oxidative damage contributes to the gradual decline of melanocyte function. Laboratory studies have demonstrated that excessive oxidative stress can interfere with pigment production and may damage melanocytes under certain conditions. This has become one of the leading biological theories explaining why hair gradually loses its color with age. Imagine leaving a beautiful painting outside in harsh sunlight for years. Day after day, the colors slowly fade. The process isn't dramatic enough to notice from one day to the next, but eventually the once vibrant artwork looks pale and weathered. Something similar may occur inside aging hair follicles. The pigment producing machinery isn't necessarily destroyed all at once. Instead, years of accumulated biological wear gradually reduce its efficiency. This understanding has changed the way many scientists think about aging. Rather than viewing gray hair as a purely cosmetic issue, they increasingly recognize it as one visible reflection of deeper biological processes occurring throughout the body. The same oxidative stress that influences melanocytes also affects skin, muscles, blood vessels, the brain, and many other organs. That's one reason healthy lifestyle habits often benefit far more than just our appearance. Researchers at several universities have investigated these biochemical changes in hair follicles, exploring how antioxidant enzymes, mitochondrial function, stem cells, inflammation, and cellular repair mechanisms interact over time. While many questions remain unanswered, the overall picture continues to grow clearer. Hair pigmentation depends upon the health of an extraordinarily complex biological system. When multiple components of that system gradually become less efficient, gray hair becomes more likely. This brings us to an important question. If oxidative stress contributes to pigment loss, could supporting the body's natural antioxidant systems help maintain healthier hair follicles? It's an intriguing possibility, and scientists have been investigating it for decades. Numerous nutrients have been examined for their potential roles in supporting healthy hair, including vitamins, minerals, amino acids, and plant compounds. Some show promise in laboratory settings. Others have demonstrated benefits for people with specific nutritional deficiencies. Still others remain subjects of ongoing research with encouraging early findings but insufficient evidence to draw firm conclusions. Unfortunately, this is also where misinformation often spreads. The internet is filled with dramatic claims promising to reverse gray hair in a matter of weeks using one miraculous supplement after another. Videos receive millions of views, products sell out overnight. Yet, genuine science rarely works that way. Human biology is incredibly complex, and lasting changes usually require patience, consistency, and realistic expectations rather than overnight transformations. Still, among the many nutrients researchers have explored over the years, one particular compound has generated scientific curiosity because of its historical connection to hair pigmentation. It isn't discussed nearly as often as biotin, collagen, or vitamin D, yet its story stretches back more than half a century and continues to spark interest among nutritional scientists today. That nutrient is known as para-aminobenzoic acid, commonly abbreviated as PABA, and its fascinating history is where our conversation becomes even more interesting.